Hey, algebra students, in this lesson we are going to be graphing quadratic functions. And you're going to notice that some of the problems are going to have little pictures of graphing calculators next to them, like these ones. Anytime you see that picture, you're allowed to use a graphing calculator or a graphing program like Algebra to solve that problem. We're going to learn that the zeros of a function are actually something a little bit complicated that you can use a graphing calculator or graphing program to find. We're also going to learn later on that you can actually, using a trick of algebra, which is kind of interesting and cool, you can find the zeros of a function on your own without using a graphing calculator or graphing formula. And it's really handy to know how to do that. That is going to be in an upcoming lesson. So this is sort of a preview to that. For now, we're going to be using a graphing program to do those ones. You know you're allowed to because you see the picture. But you'll notice that for the first three here, we're supposed to graph quadratic functions without using a graphing calculator because there is no picture. What we're going to do for these ones is we're going to just make a table of values and then graph those coordinate values and see what parabola develops. So we're going to get started with that with letter A. I always like starting with -2, -1, 0, 1, and 2. And then if I need more points, I'll go from there. Okay. So if I were to plug in -2 to this formula, what am I going to get? So I'm plugging in -2 for x. Now be very careful. I'm plugging -2 in for x. And what's the first thing that's happening to x? X is squared. That's going to happen with all these quadratic functions. If you plug in a negative value and square it, what happens when you square a negative? -2 times -2 isn't -4. -2 times -2 is 4 minus 4 times -2, okay, plus 7. Here's the other tricky part of these. A lot of times you actually do have to write out the work because the second term, if it's being subtracted, uh, if you plug in a negative, it's actually going to be a term that gets added because it's going to be minus a negative, and that's what's happening here. So this becomes 4 minus -8 plus 7. 4 minus negative is 4 plus 8. 4 plus 8 is 12, plus 7 is 19. All right, so if I were putting this on graph paper, I would have to make sure that if I have graph paper that only has 10 units above the x-axis, I would need to make sure my scale counts by twos to get the number 19 on there. Because then if it went up to 10, I would be able to get all the way up to 20 if I count by twos. But that would be the first point I would graph is -219. Let's take a look at the next. So if I plug in -1, I'm going to have -1 squared, which is just 1. -1 times -1 is 1. Minus a -4. That's going to become +4 plus 7. 1 plus 4 plus 7 is 12. So my second number here is going to be the number 12. Okay. 0 is usually the easy thing to plug in. So I don't necessarily have to show my work for this. I'm just going to plug in 0. 0 squared is 0 minus 4 times 0. Well, that's minus 0. 0 minus 0 is 0 plus 7. So when I plug in 0, I get 7. Hey, key thing. When you plug in 0, you don't always get 0 out of a quadratic function. Usually you get this last number that doesn't have a variable attached. All right, plug in 1. If I plug in 1, I get 1 minus 4. Now that our numbers are positive, this is going to be a little easier. 1 minus 4 is -3, plus 7 is 4. 2 squared is 4, minus 4 times 2 is 8. 4 minus 8 is -4, plus 7 is 3. Okay, now I'm going to notice something. I noticed that I started with my y values being really high. Then they came down, but they never started increasing again. Okay, so if my numbers don't start increasing again, I actually have to go a little further. I'm going to try plugging in a 3 and see what happens, and see if this number gets bigger from 3. Let's see if it does. So if I plug in 3, 3 squared minus 12, so 9 minus 12 is -3, plus 7 is 4. Started going up again, and now I'm done. Now, let me show you what happened. When we graph these first 5 ordered pairs, if you put them on a graph, you would get this. Notice that I have the shape of a parabola here, but I only have half of my parabola. I need some points on this side to be able to draw the other side. I need at least 1 point to show me how the shape of it goes. So I'm going to put in that last point, 3, 4. Let me just click right here, and I can do a ordered pair, 3, 4. There we go. Now, I'm going to do something that you are not allowed to do. I am actually going to graph this by putting in our equation, and let's see if our equation passes through all of these points. So we're going to do x squared minus 4x plus 7. X squared minus 4x plus 7. There we are. So you see that all of my points are on our equation. By the way, you do have to draw in the parabola. If you notice that your parabola isn't this nice, neat, um, smooth curve, you probably did something wrong and you should go back and check your work. It should not be like too steep and then shoot back up again. And it definitely isn't going to be a straight line. Make sure you check your work, especially make sure that when you squared your negatives, you ended up with a positive number. And if you were subtracting a negative, you actually added. All right, so we're going to keep on moving. First of all, this is what the book answer for letter A looks like. Notice that their graph looks a little different from this one because this one has a different level of zoom, but it is the exact same thing. They started by graphing 0, 1, 2, 3, 4. There's no way we could have known that we were supposed to graph those points. So you just pick a set of points to graph and see if they fit on your graph. If like they're way too big, the y value is way too big or way too small. Way too big is the bigger problem, right? If your y value is way off the chart, you have to choose a different x point. So sometimes there's a little trial and error involved. All right, let's go on to letter B. I'm just going to move this whole thing up a little bit, and then we'll move on to B. Okay, so for letter B, we're going to do the same thing. For x and y, I'm going to start by plugging in -2, -1, 0, 1, and 2. And let's see what we get when we plug those values in. For -2, oh man, so now I have a coefficient in front of my first one. So I'm just going to put this over here. It's going to be 2 times -2 squared is +4. -2 times -2. So it's going to be 2 times 4. I'm just going to simplify that right away to 8. Minus 16 times -2. This is going to be minus -32. So it's going to be 8 plus 32 plus 24. Okay, now here's one of those situations. That's going to be way too big a number. 8 plus 32 is already 40, plus 24 is 64. I don't want to graph 64 on a graph like this. So I'm going to assume this is coming down as I go to the right. I'm not going to graph -2. In fact, I'm going to judge that I'm probably going to start at 0 on this one. So I'm going to put 0 as my first number, and we're going to try this again with 0. If I plug in 0 to this, what do I get? Well, 2 times 0 is 0, minus 0 plus 24 is 24. 24 is still too big. Maybe if I start at 2 instead of 0, that would be a good idea. Let's see what we get when we start with 2. Okay, so you see the thought process here? If I'm plugging in numbers, I'm getting y values that are way too big and going to be hard to graph. I'm going to choose different x values to get different y values. So let's try plugging in 2. This is going to be 2 times 2 squared, which is 2 times 4 is 8, minus 16 times 2 is 32, plus 24. And I'm just looking at this mix of numbers here. 24 plus 8 is 32, minus 32. This is going to add up to 0, right? 8 minus 32 is -24, plus 24 is 0. 0 is easy for me to graph, so I'm going to include this point, 2, 0. All right, let's see what happens now if I use 3 as my x value. So that's going to be 2 times 3 squared. 3 squared is 9, so 2 times 9 is 18. Minus 16 times 3 is 48. So 18 minus 48 plus 24. All right, so 18 minus 48 plus 24. Okay, I'm going to simplify this a little bit. Minus 48 plus 24 is negative 24. 18 minus 24 is negative 6. Okay, so my parabola is still decreasing. Let's see if we can find a leveling off point. I'm going to plug in 4. So when I plug in 4, I get 2 times 16. 4 squared is 16. 2 times 16 is 32. Minus 16 times 4 is 64 plus 24. Okay. Here again, it's easiest for me to combine minus 64 plus 24 first. So minus 64 plus 24 is minus 40, right? Negative 64 plus 24 is negative 40. So I'm just going to replace this end part with minus 40. 32 minus 40 is pretty easy to calculate, and it fits on a graph. So 32 minus 40 is going to be negative 8. Still going down, but going down less and less. Let's try plugging in 5. If I plug in 5 to this equation, I get 2 times 5 squared is 2 times 25, which is 50, minus, let's see, 16 times 5 is 80. Well, this one's going to be easy to calculate. 50 minus 80 is negative 30. Negative 30 plus 24 is negative 6. Hey, we started going back up again. Let's get one more point on here. We'll plug in 6. I'll bet that 6 is going to give me 0 as a result. Let's find out. So 6 squared is 36. 2 times 36 is 72. So I'm going to write 72. That's what I get when I plug in my first x, minus 16 times 6 is a big number. 16 times 6 is going to be 96. So 72 minus 96 plus 24. Well, here again, it's easy for me to combine these last two numbers. So negative 96 plus 24 is negative 72. What's 72 minus 72? 0. Let's see if we got it right. There it is. Notice that if I plug in 0, I go all the way up to 24, but that's pretty high for a normal graph. So if I just started this by graphing 2, 0, 3, negative 6, 4, negative 8, 5, negative 6, and 6, 0, I get this nice curve shape of my parabola that would help me to visualize what I'm looking at there. We are going to do the exact same thing, but notice this time I don't have a middle x term. So this one's going to be really easy for me to make an xy table for. So when I plug in, I'm going to start again with my favorite numbers, and we're going to see if they work. Negative 2, negative 1, 0, 1, and 2. All right, let's see where these put us. So if I plug in negative 2, 2 times negative 2 squared is 2 times 4. 2 times 4 is 8. Minus 9 is negative 1. Okay, so negative 2, negative 1. Plug in negative 1. I get negative 1 times negative 1 is 1. Times 2 is positive 2. Minus 9 is negative 7. All right, I notice there's a pretty big gap between those numbers. What happens if I plug in 0? 0 gives me negative 9. Well, hopefully it's going to start going back up again now. What if I plug in 1? 2 times 1 is 2, minus 9 is negative 7. We're going back up again. And then 2 times, let's see, 2 times 2 squared is 2 times 4, 8. Minus 9 is negative 1. Here's the graph of this one, by the way, and we see that this is indeed a quadratic function. Notice that the points I graphed are down here. I included a few more than the book included, but that's good because we get to see the shape of this a little better. Okay, now Notice that for all of these, I can notice that the first term is positive, the x squared term is positive. If your leading coefficient is positive for a quadratic function, you're going to get one that points downward, like that opens upward, okay? It has a minimum and it opens upward. And what that means is I expect my values to go down and then up, down and then up. And that's what happened in all of these ones so far.